Hello internet lamp fans. I want to do an update here on this LED matrix lamp thing. If you haven't seen the other two videos about it, then you can watch those to get the background, because I'm not going to repeat the whole thing. But essentially, I saw this design online and I made one and I liked it, and I've been programming it in different ways and kind of having fun gradually improving upon the thing. So one of the problems that I had with it before was that this was the bottom section. So there's a big hole in the bottom, and it basically consisted of a bunch of wires and hanging out the bottom, and the circuit board would fall out and things like that. So I thought, I'd like to neaten it up a little bit. And also, as you may have seen in the previous video, I want to make a sort of custom control board. So that is what I'm going to talk about here, and how I sort of got to this point, which is just has a power socket on the bottom, and that's it. So yeah, what I did have previously, just to kind of drag this setup back out. This is kind of my test rig here for some stuff. So this is the Pixel Blaze board that I was using to control it previously. I really like this thing. It's available on Tindy, and you can program it in JavaScript, and that's a great way to do it. So, what I had before was this matrix was inside the lamp, and then this sort of power cord just dangled out the hole in the bottom, and then, like I said, occasionally this board would fall out because it really was kind of a big hole. And then I'm moving to programming just a bare Atmega 328p to run the patterns instead. So I had this set up. I showed this before, but essentially I've got my new C code running here. I can turn my bench lights off to make this a little more visible, I suppose. Excuse me. Yeah, the bottom one's the previous Pixel Blaze code I was using, and the top one is my new C code, and I can kind of reset this to try to get it to different things. But in any event, I already talked about this, so I'm kind of retreading ground here. But a little bit of background, I guess, for where I'm going. So let's turn these back on here. So what I wanted to end up with was a custom board that could go into the lamp. And when I was thinking about that, of course, I was thinking, well, I might as well just, really the only thing that needs to be connected to this is power. So Fusion 360 is my friend. I really like doing my CAD stuff in Fusion 360. So I had already modeled this lamp in here previously. As you can see, sorry, this is not the computer I usually do this on, so I'm needing to use a different kind of mouse control. But in any event, so this is the new model. You can probably see already there, the changes are in it. So what was fun was kind of to just take this. I can take the top off here so we can look inside. And you can see I've got the board here mounted in there, and I've got the power connector mounted in there. And yeah, that's basically what I did. So we'll turn this off, and we'll turn these off. There we go. A little better view. So I was able to find online, somebody had already done a CAD model of this particular panel mount barrel jack that I had in the parts drawer. I think I got it from Adafruit, but they're commonly available. So I actually was able to download this model that somebody else made. Super convenient. I just dropped it into my design, figured out where I wanted it to go. Same thing with this perf board, actually. It may seem like a trivial thing, but I had some perf board, and I searched around and I found a CAD model of someone who had the exact same model and size of perf board. And the reason that was somewhat important to me was because they modeled the screw holes, and having the screw holes in exactly the right place, I could have measured it and made a rectangle with some holes in the corners, but I was able to find that and just drop it right in, which was cool. And then the screws, as you can see there, I did model the screws and the standoffs. Actually, I didn't model them. I clicked up here, insert this is cool, insert a McMaster Carr component, and you can just go in here and go to screws and bolts and search through and find the right thing. So I knew that I wanted an M2 nylon screw, and so I just went in there and I got that part, and I dropped it in the design. Same with the standoff. So that way I was able to see exactly how this would go together, and then turn this off, and I guess I can turn these off too. So again, not used to using this Windows computer to do this. There we go. Yeah. So then I made the holes in the right places with that, and then I went to CAM, of course, because having a laser cutter means that you can just go in and just have the wrong stuff displayed. But in any event, I was able to go in and create the laser cut and just make a new bottom piece for this very quickly. So that all being said, that leads back to where we started, which is, so I can take the top off here with gentle persuasion. And so it's a little bit messy in there for reasons. So inside you can probably see there's a circuit board in the bottom, and there's the barrel jack connector. And I can actually, if I disconnect, part of the reason it's messy is because I left myself cables that I could disconnect in order to make it easier to take this thing apart. So now I can take the bottom off. This is deliberately not glued in, at least not at this juncture. But you can see there are the screws. It takes just a little bit of effort to prise this out. I want to do it carefully, even though I'm under a bit of a time constraint here, because I know the videos get long and boring and people drop off. But we're going to just carefully go around until it lets go. There we go, it let go. Now I can just keep going. It really is exactly the right fit, so that it friction fits without any danger of falling apart, but it is possible to take it apart. Okay, there we go. So that's the lamp disassembled, and yeah, so here's the board, just like we saw on CAD. I've got the screws in the bottom and standoffs, and then I've got this this barrel jack, sorry about the focus, barrel jack connector here. And then, like I said, what I did was I sort of attached these pigtails so that I can put that on there, because I can actually, I didn't show this working. I should have shown it hooked up. Let's pretend just for a moment that I put this back together. I won't fully put it back together. Just enough to plug it in, because there were two things I wanted to say. There we go. Stuff the wires up inside there. Once it's all enclosed, it looks neat. Neat enough. Okay, let's say that's good enough. So I can plug this in, turn it on. There we go. Yeah. So just to demonstrate that it does work. So everything is fully functional there. Now we can take it back apart. Disconnect, disconnect. Okay. I wanted to take this board off so I could show you the build process. The next step will be to actually order, first design and then order a custom PCB. But the step right before that is to prototype the thing. So there's just a little bit of effort to take this apart. I should have loosened the screws before starting the video. Okay. So I took advantage of the fact that this perf board already had screw holes in the four corners. So I just matched that up with screws of the right size. Anyway, what is on here is the Atmega 328P, the recommended bypass capacitor. I only had this 25 volt one, so the capacitor is rather comically large, but that's the one I had in the parts drawer, so that's the one I used. And a resistor here on the data line, as is recommended when connecting to WS2812 strips. And then really the only other thing that's important is the connections out to the thing. I put these on pin headers. Sorry, I really could have done this with a nicer camera. But I use these DuPont connector slash, pin headers, whatever you want to call them, things, just again to give myself an easy connection here. I don't like soldering wires directly onto the board. In this case, I did with the power, just because I didn't have anything good to connect this onto. I have some screw terminals, but they don't fit, so I ended up soldering that on. Anyway, I want to talk a little bit about the wiring in the back. So, yeah. I guess I'm not the best at sort of perf board wiring, but I ended up, I think, doing a reasonable job. But this takes forever. I kind of hate it. I thought at first I might make a few of these, but this will be the only one. So I did put on here, you might notice there's some other pieces. I added an ICSP header so that I could program the thing from here. That was the thought. I added a reset button, and I added an FTDI style 6-pin header that I could, if I wanted to connect to the serial port. I put all of those things on there because all of those things are on the this evil mad scientist Atmega prototyping board. So I found that I was using those things, obviously using the programming header. I ended up connecting serial port and other stuff. So I thought, well, I'll put this on here while I'm at it to figure out the layout. But I ended up not wiring all this stuff up because it's just a whole bunch more pins that I don't need. I'm never going to program this once it's inside the lamp. I did put the chip in a socket, so I can just remove the chip, reprogram it, and replace it. That would be much more likely. So in any event, once I put those components on, but I didn't wire them up. So this is sort of the minimal setup right now. I just have the chip. The only connections to it are for power and the one data pin. And then I have the two passive components, and that's really it. So that's the deal. So yeah, next I will go and I've already started relearning EagleCAD, because every single time I do one of these things, I've forgotten how to use Eagle. Not that I've forgotten how to use it. That's not exactly true. I start using it and then I feel like I don't know what I'm doing, and there must be some important facts that I've, I'm going to do something wrong because it's something I'm out of practice with. I'm just shoving this back together because I wanted to make one final point, and then this video will finally be over. So let me reconnect this guy. I've also started doing a thing now with these matrices. You might notice there's a bunch of extra stuff. So they come like this with in, out, and a power connector in the middle. So now when I do this, when I have the soldering iron out, I remove the out and the power connector. I don't need them. And I just leave the in, and then I put electrical tape over that so that it doesn't short against anything, because otherwise there's all that unnecessary extra crap banging around inside. And who wants that? Okay, so now you have to bear with me for a moment while I put the bottom plate back on here. Eventually, I'm only going to be able to do this so many. Now I haven't screwed that on because I'm trying to save precious seconds. So hopefully my proto board will not fall off. Let me see if I can get this on here. The trick is getting it on. There are 4 sets of legs, if you kind of get it on there, then it goes the rest of the way very easily because it's already lined up. There we go, perfect. Okay, so that's the finished product there, and I could probably even put the top on as well. Yep. Nice. So it's all back together, right? Here's the problem. As always, you do these things, and there are physical constraint issues that you might not think of until it's a little bit late. So I have this nice socket in the bottom, and I can plug that in, and I can power it up, but yeah, you see the problem here? These barrel jack things are longer than the feet. So they're always longer than the feet, and so this doesn't sit on the table anymore. Now I did, it wasn't like this was a total surprise, but this is the part that I had, and I sort of stared at this for a while, and I thought, well, panel mount connector, that's what logically goes in here. And there are some ways around this, but without fundamentally redesigning the lamp, none of them are really trivial. I guess I could have some kind of board that comes out and then goes out at a right angle. But my solution to this is to purchase a 90-degree adapter for barrel jack connectors. So those are on their way from Amazon, and hopefully they will fit. Now, this is not very deep, so some of those 90-degree connectors actually are longer. They don't save space, they just change direction. But the key is I want something that'll save space here. So that's a bit unfortunate that I, don't have an obvious way to put a power connector on this without it being ugly. So yeah, and then final thought was maybe some switches or something. It might be nice to have a power switch, it might be nice to have a reset or next pattern, and it might be nice to have a brightness control. So I was thinking about putting those on the top, but of course at that point now the top is not I don't think this design really calls for having switches and things on the top. I think it calls for having a nice engraved picture or message or something on the top. So anyway, I'm babbling on as I do. I have trouble ending these videos. So just wanted to talk about where this is and kind of show the circuit board in there. Oh, and by the way, I completely forgot to mention in the last video, and I said I would, what I ended up using for the code for this thing is the Fast LED Arduino library, which is great. I was planning to try a bunch of different ways to do this, and I spent a lot of time reading about how to control WS2812s and writing the hand-tuned assembler code or using various tricks and UART things to pump stuff out. So I initially thought that I would go as low level as I could possibly go because I wanted to save a lot of memory, and I wanted it to be fast and reliable. And I thought I don't need all the features, I don't need all the bloat of various libraries, so I will hand code my own. But I started with Fast LED as like, let me see what I can do with this, and then when it gets to be too, gets in my way, I will replace it. But it never got in my way. So in fact, it's very convenient and made a lot of things easier. So I ended up using that. And so sort of shout out to the Fast LED folks. It is a great library. And with that, I think I'm finally done. I'm going to shut up and post this.